Hello students. Today we are in lecture number 6 of standard 11. Okay, it is lecture number 6 and the topic will start. It is vector. This is the very important. Alright, the vector analysis. Remember students, this particular topic is not only for this chapter, but this is for entire physics, for standard 11th, standard 12th, and you will feel without vector you will not proceed physics in proper way. So you have to be very careful while studying this topic. This particular topic you will find in chapter number 4 of NCERT. It is written, the chapter Motion in Plane. We are studying chapter number 4, the topic of chapter number 4 here before the chapter 2 and 3, because this vector will be helpful in chapter number 2 and 3, that is kinematics. Alright student, so we are going to start here the vector analysis. This is the chapter number 4 of NCERT. My dear student, this particular topic we have a study in standard 9 also. Teacher used to tell you about the physical quantity. So let me start from there only. Here the physical quantity. If you will categorize, you will find in 3 types. Alright, it is first scalar, second it is vector, and the third one it is tensor. Alright, these are the very famous scalar and vector quantity, but the tensor quantity very hardly you hear in your course. Today we'll study about the scalar and vector, and at the end of this chapter, that is the topic vector analysis, we'll study about the tensor quantity also. Alright, so you all are very well aware about the scalar quantity. Scalar quantity. My dear students, you can write the definition of scalar quantity, although you know very well the definition of scalar quantity. Remember, scalar quantities that consist with magnitude only. Alright, it has magnitude only. Magnitude only. This is the very important. Only magnitude. Okay. It means for their representation we required only the amount but not the specific direction. Remember, if we are telling about the amount, actually only the amount, it means we are dealing with the scalar quantity. Let me give you some example. If we talk about the mass, alright, mass. Mass. Whenever we talk about the mass in physical quantity, the chapter unit and measurement, you have studied about the unit of mass. Whenever we talk about the mass, you go to the market and you ask the shopkeeper to give you 10 kg of potato, alright, or the sugar. My dear students, ever you say the shopkeeper, kindly give me 10 kg sugar north, or 5 kg potato in upward direction? No, you never give the direction. Actually, you ask about the quantity only. That's why the quantity, those are used to represent their quantity or the amount without the specific direction are considered as the scalar quantity. Alright, length can be also considered the scalar quantity. Remember, length. But length can be a scalar or vector. Length, it is distance, and length is also the displacement. Alright, so when we talk about the length, it could be the distance or displacement. But here I am talking about the distance. For example, if you say to any person, my home is 5 kilometers from here, then it is distance. You are not specifying any direction. Yes, it is 5 kilometers due east or 5 kilometers due west. Only you are giving the quantity, the length, which is from your you are here. Okay, so it is the quantity only. Here the distance is a scalar quantity. All right, you are not specifying any particular direction. Another example, you can take the temperature. All right, the temperature. We do not say, all right, we do not say that today it is 37 degrees Celsius in upward direction. Yes, we never specify any direction. In atmosphere, if we are facing that temperature is 37 degrees Celsius, 35 degrees Celsius, 40 degrees Celsius, so we only give the amount. Yes, it is 37 degrees Celsius, 35 degrees Celsius. All right, we never give the direction. It is 36 degrees Celsius in rightward. It is 36 degrees Celsius in downward direction. No, never. So whenever you specify the quantity without specifying any particular direction to any quantity, any physical quantity, then it is considered as a scalar quantity. The last example, you can say it is energy. All right, this is also another example of scalar quantity. It is energy. All right, energy. We don't say 50 joule in north direction. Okay, 20 joule in upward direction. We only represent as quantity. So this is the scalar quantity. For example, it is the 50 joule, 50 calorie. These are the example of a scalar quantity. All right, my dear student, I hope you understand about the physical quantity, the scalar quantity. All right, now we will discuss about the vector quantity. Let me wrap this. So the vector quantity, student, the quantity which possesses magnitude and direction as well as they obey law of vector addition are considered as the vector quantity. Remember, I am writing here what are the required condition for the vector quantity. If any physical quantities, then magnitude, it should have magnitude, it should have direction, all right, and obey vector law. All right, obey vector law, vector laws of addition. Might be there are number of quantities that are having magnitude as well as direction, but that are not the vector quantity. Why? Because they do not obey the law of vector addition. The very famous example is electric current. All right, so whenever we talk about the vector quantity, it should have the three things: magnitude, direction, as well as it should obey the vector law of addition. Alright, so these are the vector quantity. My dear students, we will discuss in very detail about this vector quantity, but here I am giving you the example, the very simple example. Take force. Why this is vector quantity, sir? Okay, remember, you need magnitude and direction to represent the vector quantity like this force. When you talk about the force, that is the 50 Newton are applied. Okay, I applied 50 Newton over this board. It means the 50 Newton I am applying in any particular direction. Okay, if I punch you with 500 Newton, then in which direction I'm punching you, it has a particular direction. Yes, I'm punching you in this direction. Alright. It is not that I have punched you in any direction, that I punched you and the force goes in different direction. No, it has a specific direction. If I punched you with 100 Newton, if I punched you with 500 Newton, then it must have a particular direction. Alright, so this force. And why this is a vector quantity, what is the meaning of this? It obeys vector laws of addition. Okay, so to understand this particular thing, that it obeys the vector law of addition, I am explaining here an example, the very simple example. I hope that you will get it. Okay, before that we will discuss remember about a few more quantities, that is the vector quantity. Here, suppose, my dear student, you are having a brake. Alright, and you start pulling by 10 Newton in this direction and another one by 5 Newton in this direction. Now, could you show me that in which direction this brake will start moving? Whether this brake will move towards the 10 Newton or towards the 5 Newton. It will go towards the 10 Newton or it will go toward the 5 Newton. The answer is it will neither go along the 5 Newton, 10 Newton or 5 Newton. Actually, it will go in between these two forces in this direction. What does it mean? It means this is a resultant value. Okay, the resultant force. What is the meaning of resultant, we will study, but this is the resultant force and it moves along the resultant force. And remember, this resultant is not 15 Newton. This is not 15 Newton. Remember, this is not 15 Newton. So what will be the value actually? We will study. Suppose why it is not 15 Newton, I am giving you an example. If you are adding this 5 Newton and 10 Newton as 15 Newton, then what will happen if the force is little bit more diverted? If this is 10 Newton and this is 5 Newton, then again you will say yes, it is 15 Newton. Alright, this is experiencing a total force 50 Newton, but whether this will move due to the 15 Newton? Answer is no, it will not move due to the 15 Newton. Okay, if you are telling this is 15 Newton, sir, then I will tell you, okay, suppose you are acting the force now in this way. This is 5 Newton, this is 10 Newton. Now, will you say that the net force is 50 Newton? Answer is no. This is 10 Newton, this is 5 Newton. So the net force will be 5 Newton in upward direction. This 5 Newton will be cancelled out by this 5 Newton. And this brake will move in upward direction. But with which force? The force is only 5 Newton. It means you are not simply adding the forces to get the net force. You are having some particular concept. Here you cannot use to represent, to add this 5 Newton and 10 Newton, okay, easily, algebraically, by ordinary method. You need some proper method, and that method was okay, studied and it was designed, that is called the vector that we have to study. All right, student. Now, let me discuss. Student, have you ever experienced the vector in your life? Let me show you some vectors. Here I have made for you. I will use this vector in letter course. I have made this vector. You can see this is the vector. This is also a vector. Here another vector I have made, and this is another vector. You can see these are the vector. But my question, have you ever seen vector in your life? So why we are studying this vector? Have you ever seen this vector or this type of vector in your life? Okay, let me tell you the example. Yes, you have seen the vector. All right, you have seen the vectors in your life. Where? Have you ever noticed signboard or sign mark? These are the best example of vector. This is a signboard. All right, it being installed for the helping customer to show the direction. Suppose it is whatever the X, Y, Z shop. All right, and this arrow represents the direction. Yes, you have to go in this direction to find that shop. Okay, if the shopkeeper is very much educated, he or she will write 5 meter. You will go 5 meter in this direction, you will find this shop X, Y, Z. Okay, so this signboard is an example of vector quantity that he or she used to represent. Another sign mark. While going to your home or on the journey, you will find across the roads there are number of sign mark are placed like this way. Okay, so this is over the road. It is written Patna 50 kilometer. What does it mean? If across the road the signboard is placed in left side, it means you have to go in this direction. Actually, this is giving you the direction. All right, like this way, this was giving the direction. So this is giving you the direction. Remember, you will go in this direction 50 kilometer, you will reach to Patna. This sign mark does not mean that you will go 50 kilometer in any direction from here, in any direction. If you are going here, you are going here, here or here, you will find Patna everywhere. Okay, it doesn't mean. You have to go in a specific direction, and in this direction you will get the Patna at 50 kilometers. So this is another example of vector quantity. All right, my dear student. Now we are going to start our course. This was the brief introduction of the vector, what way you experience in your life the vector quantities. Now we are going to discuss about the vector quantity that we have to study, and that will help to solve the questions in our course. Okay, let me wrap this, my dear student. I'm training you to solve this vector quantity, but before that formula, you must need to understand what is vector quantity so that you can also teach your juniors. All right, now first, the geometrical representation of vector. All right, geometrical representation. Geometrical representation. Remember, a vector is represented by arrow. All right, arrow, this one, like this arrow I've represent, I've made for you. You can see this is the vector. Here, this point, actually the arrow, you will see it is made like this way. This, you can see it is the pointed. That's why this is called, this portion is called dot. All right, dot or head of the vector. And this one, actually this is made, used to made like this way, and after designing this point it is cutted out. Okay, engineers used to design in this way, and so this is called cross. All right, or till. And the length of, so you can say this one as dot and this one as cross. This cross is the origin from the vector. This vector is starting and it has to go in this direction, and this is the ending point, that is the dot. The length of this vector will represent the magnitude. For example, this vector is greater than this vector, although both the vector having the same direction. You can see here the same direction. I'm changing the direction. Yes, here the direction is being changed, but here in this way the direction is same, but the magnitude of this vector is little larger than this vector. Okay, so length of this particular vector, length, okay, this length is the magnitude, represent the magnitude when we talk about the geometrical representation. Okay, if you are making the vector, this one as vector, and you are making this vector as a dash, it means magnitude of a dash is larger than the magnitude of a. All right, okay. Now head gives the direction. Remember, head gives the direction and length gives the magnitude and tail gives the origin from where the vector is starting. All right, now we will do the symbolic representation. Symbolic representation. As a symbolic representation, actually we use an arrow to put over the quantity to make it is a vector quantity. For example, if you're writing this A is vector quantity, you have to put an arrow symbolically. Remember, if any vector is going in this direction, you are not supposed to put in this way, and if any vector is going in this direction, then you are not supposed to put in this way. Remember, this is the wrong representation. This will be the representation only. This is symbolic representation. You don't have to represent. If the vector is in upward direction, then you will make A in this way. No, these are the wrong. This is only the symbolic. You have to put an arrow over the head of quantity, and that will make this is a vector quantity. All right, if you are putting here the x, then it is called vector x. Vector x. If you are putting r, then it is vector r. All right, so these are the representation basically. Okay, student. Now next we will discuss about the direction of vector or angle between two vector, how to represent the angle between two vector. All right, so let me wrap this. Kindly write down, my dear student, direction or angle between two vectors. Okay, so the very important point you should write, angle must be considered with head to head or tail to tail. I hope you have written in your notebook. Again, I'm telling you, angle must be considered with head to head or tail to tail. What does it mean, sir? You have to find either head to head or tail to tail. This is very important. Okay, how? Okay, let me take this two vector. If you are going to find out the angle between this vector and this vector, all right. So if these two vectors are inclined in this way, you can see here the angle between these two vectors. This is the theta and it is correct. So kindly make the diagram. This is correct. All right. If you are making in this way, here in this way, and this is theta, this is also correct. Okay, but if you are making any vector in this way, like this way, all right, and if you are writing this is at theta, then it is wrong. Why? Because you are calculating here the angle between head and tail. What I told you, either you can find out between head to head or tail to tail. So this is head to tail and the angle is not theta. So what will be the angle, sir? So you will proceed along the vector line. Okay. And now this is 180 minus theta. So the angle between these two vectors will be 180 minus theta. So always remember, you have to represent the angle between two vectors either using head to head or tail to tail. Although I have made here the vectors using this, but I'm writing here that you have to make your note. Suppose a vector A or vector B. So this is the correct representation. If you are making this vector like this way, vector A and vector B, this is the theta, this is also the correct. You can see here between tail to tail we are considering, here between head to head we are taking. But if you are representing like this way, vector A and this is the vector B and this is the theta, then this will be wrong. So what will be the angle here? The angle will be 180 minus theta. Okay. So this was very important. You have to represent the angle between two vectors either from head to head or tail to tail. Okay. Here, let me ask a few questions, my dear student. Here I am giving you an example and you have to find the angle between the two vectors. Okay, which is very important. Okay, now you can see three vector I am making. This is equilateral triangle. All right, this vector is going in this direction. Remember, it is not important to show the vector head at the end. Now, because you have studied already and you are trained now, so I can represent the head anywhere you will get it. So these are the three vectors. Suppose the vector 1, 2 and vector 3. Any quantity if is having an arrow overhead, it become vector quantity. So it is equilateral triangle. Okay students, equilateral triangle. Now my question, what will be the angle between vector 1 and 2? Kindly tell me the answer. What will be the vector angle between these two vector 1 and 2? Could you tell me the answer? The next one, if you can find out the answer, kindly write down over your note. Now, the next one, what will be the angle between 1 and 3? Vector 1 and 3. What will be the angle between vector 2 and 3? Vector 2 and 3. What is the angle? Now, answer. Let me find out. Here, between 1 and 2, you can see this head is going to put over here. So this will be the angle between this two, and it is 60 degrees. So the answer is 60 degree. Now 1 and 3, you can see the tail of the 1 and tail of the 3 both at this point. So it is again the 60 degree. Alright, now between 2 and 3, you can see the head of this vector is over here and tail of this vector over here. So this will be not the angle. Alright, this will be not the angle. So what we will do, we will proceed this vector further, and this will be the angle, and it is how much? 120 degree, because it is 180, and it is 60, then 120 degree. So in this way you have to find the direction and angle between the vector. Okay, my dear students, so the last I'm giving you the homework. We are running out with the time of today's lecture, so I'm giving you here the homework. You have to kindly note down this one, to find the angle between two vectors. This is very important topic, vector, so we will not move very fast, but slowly we'll try to understand everything here. This is square, this is a square, the diagonal I'm using for the vector here. These are the vector 1, 2, 3, 4, and this diagonal is the vector 5. Okay, over all the vectors we are having arrow. All right, I'm not representing due to the very less space. It will be the hodgepodge. So now the question, this is your homework. You have to find the angle between all the vectors. Remember, all the probable vectors. What are the probability? So you have to first make the combination 1 2, all right, 1 3, 1 4, 1 5. In this way, could you make the all combinations? Yes. So this is your first question. A, B, C, D. What will be the E? So it is 2 3, 2 4, 2 5, 3 4, 3 5, and the 4 5. All right, F, G, H, I, and this is Z. 4 5. Okay, now you're having all the possible combination. You don't have another vector, so you have to find the angle between all these vectors. Okay, and next class, students, we will study about the for a few topic of this vector. Probably we'll start from the magnitude and direction of the vector, and we'll proceed for the types of vector. Okay, my dear students, so this is all about the today's lecture. Thank you very much.